Hello and welcome to my channel, and in this video we'll learn about pandas. We'll start with basic functions of pandas, and we'll learn some advanced topics which are regularly used by most of the data scientists and data analysts. So Python is basically a data analysis tool, which it is an open source data analysis tool, and it is widely used by data scientists and data analysts. So if you wish to get into data science or data analysis, then this is the perfect tutorial to start with. So let us just start to code now. So I start by importing the numpy library as np and the pandas library, I call the pandas library as pd in this example, and this is the standard one. So I'll run this part of code. Okay, so next we create a data frame. We create a data frame using the pd.dataframe function. But what is a data frame? A data frame is basically it is something like an SQL table. It consists of rows and columns. The columns have names and the rows have integers such as 0, 1, 2, 3, something like an index. So that is a pandas data frame, and we create a pandas data frame using pd.dataframe function. Pd is pandas here. I have given it a shortcut here while importing it. I create a data frame. I name the data frame as my data frame, and I load the data in the data frame as a data variable. And let us take a look at the data variable here. Data variable is a list of dictionaries. The X is the column name, the Y and Z, these are the column names, and the integers 12, 24 and 31, these are the respective row values. The second dictionary consists of the column names X, Y and Z, and these integers are their respective row values. Similarly, this is the case with the third dictionary. So I'll run this part of code and I'll call the data frame name in order to see the data frame. So I'll run this part. So as you can see here, this is a small basic pandas data frame. These are the columns, and these are the rows, and these are the index of the rows. So this was a small pandas data frame, but in reality there will be we will be dealing with a data frame which has more than a million rows or more, hundreds of thousands of rows, and maybe in some examples there will be more than 100 columns. So let us take a similar example here. This doesn't have many columns, but this one does have many rows. So you can import various types of files in a pandas data frame, such as a CSV file, an XLSX file, or a JSON file, or you can even import an SQL table. But in this example I'll be loading a CSV into my pandas data frame. So you can load any other file in a pandas data frame, but in order to load a CSV, you can use the pd.read CSV function, and I'm naming the data frame as data frame for simplicity. So you can load the data CSV or a file using read CSV function, and you have to mention the location of the file here and the name of the CSV. So I'll show you how to do that. So this is where my file is located. I'm taking an example of the Chicago crime data. I'll link the data in the description below so you can download it from there. So you can just copy this location from here, and you can paste it here in these quotation marks, and you have to mention the name of the file. So I'll copy that as well. It is Chicago crime data, and I'll copy this and I'll paste it here. Since it is a CSV, I'll give it an extension of .csv, and I will run this part of code. So it successfully reads the CSV, and it loaded the data from the CSV into a data frame, and the name of the data frame is data frame in this example. So the next function is dataframe.head. This function will give us first few rows of the pandas data frame. So I'll run this part of code, and as you can see here, these are the first few rows out of the many hundreds of thousands of rows that are present in this data frame. These are the rows, these are the rows and their indexes, and these are their column names. There are various columns like ID, case number, data, and you can explore this. So the data frame.head function gives us the first few rows of the data frame, and the data frame dot tail function gives us the last few rows of the data frame. So data frame name dot tail gives us the last few rows of the data frame. As you can see, the index number, the index or the row number is 265 something, 2,65,000 something. You can just explore it. Next, we use the data frame shape function. This gives us the shape of the data frame. I'll run this part. What this means is the first item of this particular output means the number of rows in the data frame, and the second part of the second item tells us the number of columns. So there are approximately 2,65,000 rows in this data frame and 22 columns. So now I want to next function is data frame dot columns. This function tells us the names of the columns that are present in a data frame. I'll run this part, and as you can see, these are the column names: ID, case number, date, block, latitude, longitude, and location. You can compare it here as well, the ID, case number, various columns. So the data frame dot columns gives us the column names of the data frame. Next, data frame dot info. This gives us a small summary of our data frame. I'll run this part, and as you can see, this is the number of rows of a data frame, and this is the number of columns, data columns. These are the column names of a data frame, and these are the number of cells which hold data, non-null cells of our data frame. And these are the object types of the particular column of the data frame. For example, the ID column holds integer values, the block column holds object values, and the year column holds integer value. As you can see here, the data type, there are 2 pool data types, 6 float data type columns, 4 integer columns, and 10 object columns. But there is a small mistake here. It's not a mistake, but you have to change the data type, the date data type. The date data type is mentioned as an object here, but actually whenever you're dealing with a time series analysis or similar, whenever there's in short, whenever there is a date column, you need to convert that column to a date type object. Instead of this particular data type of object, you want the date column to be a date type column. So we'll do that in the next function, but before that I'll show you how to select a particular column. For example, I want to select the column FBI code, FBI code. So basically, how to select a column, you mention the data frame name, open a square bracket, and write the column name in quotation marks in that particular square bracket. This is how you can initialize a column. So I'll run this part, and you will be able to see the details of the column. This is the data that holds in that particular column. So next, I'll teach you how to convert the data type to a date type. You use the pandas dot toDateTime function. I call the pandas dot toDateTime function, and I load the column that I want to convert to a datetime column, and this column will be replaced by data frame and a date column. Similarly, I want to even update the updated on column, because even this column holds date. So I call the pandas dot toDateTime function, and I load the column in that function, and I'll run this part of code, and then you will be able to see that the date type will be converted from object type to a date type function. So now I'll run this part of code, and it will take some time in order to run this part of code, so be patient for that. So as you can see, this part has finally finished execution, and the data type of these 2 columns, date and updated on, has been converted to date type. Now I'll run this info part of code once again, the summary part, in order to see if the change has taken place. So I run this part of code, and as you can see here, the date column has changed the data type from object to date time data type. Similarly, the updated on column has changed the data type from object to date time column. So this is one of the important part to deal with whenever you have columns which hold dates. Next, let us find out the minimum value and the maximum value that a particular column holds. For example, I want to find the maximum value of a particular column. Let's take an example of the column word. The column word holds integer values. As you can see, the column word holds integer values. So I want to see what is the maximum value in this particular column and what is the minimum value in the particular column. So I am taking an example of the column name word, and I'll run this part of code, and as you can see here, 50 is the maximum value in that particular column. Similarly, I want to see the minimum value of the same word column, and I use the data frame name. I select the column which is word, and I use the .min function in order to find the minimum value of the particular column. So 1 is the minimum value. Similarly, I can find the sum of the values in that particular column, and similarly I will be selecting the word column. I'll use the .sum function in order to get the sum of all the values in that column. So the sum is something around 6 million approximately. Similarly, you can even find the mean of the particular column word, and I'll run this part, and the mean is something around 23.43. These functions are really important in data analysis. And similarly, I want to find the median of the word column. I select the column and I use the median function, and yeah, this was it. The median is 24. The next thing which we are going to see is how many cells in a particular column do not hold any value, or there are empty cells. Because so let us just run this part of code. I take the data frame name, and I use the is not available .sum, the sum of all the not available values in that particular column. So I'll run this part of code. As you can see here, the ID column has 0 null values, but the location description has 745 null values, and the x coordinate and y coordinate have 1700 null values. So most of the time it is there are two cases that you can do in order to deal with null values. Either replace the null values with some value, or delete the rows which hold null values. This depends upon the scenario or the type of data that you are dealing with. I'll show you both the cases. In the first example, I'll select the data frame, but what I want to replace the null values in the column word. So there are total 3 null values in the word column. So I'll replace all the 3 values with a value 25. So I select the column and I use the fill any function. Fill any function will fill up the particular not available cell with some value, and that some value I'm taking it as 25 in this example. So I'll run this part of code, and I'll again run the dataframe.sna.sum function in order to see. I'll get a similar list, but in this after executing, the null values in the word 3 will be changed to 0. So I'll run this part, and as you can see, the word column does not have any null value anymore because I replaced the null value with some value which is 25. And next either you can replace the value with some assumed value, or you can delete the rows. So now I'll show you how to delete the rows. You can use the data frame.drop any function. The drop any function will drop the rows or columns containing the null values. So I'll be using the axis is equals to 0. Axis is equals to 0 means rows, and axis is equals to 1 means columns. And in place function, in place is equals to true, will replace the output with the same within the same variable. So the drop any function will drop the rows containing null values. So I'll run this part of code, and this part of running this part of code will drop the rows which hold null values. So I run this part of code. Now once again I run the dataframe.info function in order to get the simple summary of our data. So as you can see, the number of rows has decreased. The number of rows was earlier, it was something around, let's check it out once again, it was something around 2,65,382, but now after deleting the NA rows, the number of rows has come down to 2,63,000 now. So this, and the columns, number of columns are 22 because we did not delete any column. And if you can see here, all the cells have some value because we deleted the rows which did not hold null values. Now let us just see initial few rows of our data frame by using the dataframe.head function. So there is one problem here. As you can see, the row, the index value is 6, 7, 8, 9 and 11, because if you can see here, the first few rows, initial first few rows 0, 1, 2, 3, 4 had some null values here, and because we deleted the rows which consisted of null values, these rows got deleted, but the index values, the indexes did not get reset. So we use a dataframe.reset function in order to reset the index. So we'll come back here once again. We use the dataframe.reset index function in order to reset the index. So in place is equals to true means it will load the changes in the same variable, and drop is equals to true. Drop is equals to true will drop this index and replace it with the newly created resetted index. So I'll run this part of code, and once again I'll run the dataframe.head function in order to see it. So as you can see, the data frame index has been reset from 0, and there are no null values as well. Next, I'll teach you how to select a particular row of a data frame. We use the data frame name .iloc function in order to do that. We use two square brackets in order to do that. And let's suppose I want to see the row number 67th, and I'll run this part of code, and I'll get the row of the data frame with the index number 67. So as you can see here, the index number is 67, and this is the 67th row of the data frame. Now this is how we can select a single particular row of a data frame. But what if I want to select not just one particular row, but a row in some particular range? For example, I want to select a row between rows between indexes 2 and 10. So you can do that by using dataframe.iloc, similar function, but instead of two square brackets you use just one square bracket. And I want to select the rows between indexes 2 and 10, so I use 2:10. You remember the indexing in Python starts from 0, so it will start from 0 and then it will end at the 9th row. And run this part of code, and you will be able to see that. So executing this part, after executing this part of code, we were able to get the rows between index 2 and 10. Now similarly, what if I want to select particular columns of a data frame? Yes, you can do that. We already saw selecting a single column here while starting the tutorial. We saw here we selected a single particular column, dataframe.fbi code, dataframe FBI code. But now I don't want just a single column, but I want to select two columns. Just like rows in a particular range, I want to select two columns. So I'll use the data frame, and instead of ILOC or some other function, we just mention column names here. I want to select columns word, and another column that I'll select is let's suppose date, and I'll run this part of code. So as you can see, we selected two columns word and date. So this is how we we select two particular columns, but what if I want to select columns between particular rows? So let's suppose I want to select the columns award and date, but only between some number of some index of the rows. So we can do that by, it is pretty simple and straightforward. I'll use the award column and another column will be date, and I want to select the columns between indexes 5 and 15. This was just pretty simple, and this thing will give us an output of 2 columns and approximately 10 rows. So I'll run this part of code. So as you can see here, these are the 2 columns that we selected, and the rows between indexes 5 and 15. This was one way of achieving this output. The second way is using the Dataframe.ILOC function. We separate the rows and columns using a comma here. The values before the comma indicate the rows, and the values after the comma indicate the columns. So we mention the range of the row indexes here. So we want the rows from 5 to 15, and the columns, I want the columns to be between column numbers 2 and 5. So I'll run this part of code and I'll get the output. The rows are between 5 and 15, and the columns are between the second column, third column and the fourth column. Now this was one way of selecting rows and columns. Now what if I want to get the last row of a particular data frame? So that I can do that by using the Dataframe.ILOC function, 2 square brackets and a -1 inside it. I run this code and I got the last row of the particular data frame that I selected. Next I want to select the last column of a particular data frame. So similarly I can use the Dataframe.ILOC function. I'll use the same logic that we used here, the Dataframe.ILOC function, but instead of 2 is to -5, I will be writing a -1 there. So I'll be writing, I want the rows, instead of selecting all the rows of the column, I'll just select the rows between 2 to 5 to 15, and I'll separate it by a comma, and I'll write a -1 here, and I'll run this part of code, and as you can see, I was able to select the last column of the data frame, and the rows were between the range 5 and 15. Now this is one of the most important part in data analysis. You want output based on values from multiple columns, but before that we'll deal with a single column here. Let's suppose I want to get the rows where the value in the column is less than or equal to something. Let's consider an example of the column ward. I want to get only those rows where the value in the column ward is less than 35. So I am selecting, how do I do that? I select the Dataframe.loc and I load or mention the data frame. I want to compare the data frame column ward, and I want to compare it with a value 35. I should get only those rows where the value in the column ward is less than 35. So I'll run this part of code. As you can see here, we get a data frame where the value in the column ward is less than 35. If you scroll down, you won't get even a single row where the value is greater than 35. Here we got a conditional output based on just a single column, but what if I want to get a conditional output based on multiple columns? So let's take a look at that. I'll use a simple AND operator in between. I want to compare the ward column with primary type. So I want output where the ward has a value which is greater than 35. Now I'm changing it. Earlier it was less than 35. Now I'm taking greater than 35, and I want the primary type to be homicide. So what output will I get after executing this? I will get the rows where the primary type is homicide and the value in the word is greater than 35. This is something like a conditional output. I am mentioning the conditions here, dataframe.loc, and I mentioned the condition of the one single column, that is data frame. This is the word column, and the second condition is that the data frame primary type should be equal to homicide. So now this is the AND operator, which means that both the conditions should be satisfied. So now I'll run this part of code. So as you can see here, the primary type is homicide and the column word has values which are greater than 35 now. Earlier those were less than 35. Now next what we'll learn is how to split a column into two. Let's take an example of the last column, location. Here this doesn't look proper. It looks proper, but I want just to take an example. I want to split this column into two columns. So I will split the column with a comma here. I will split the column by comma. So I split the column into two columns. I split the data frame.location column into two columns. The first column will have the column name lat1 and the second column will have a column name long1. And I'll split the column. I mentioned the column here, data frame location, and I use the string function and I split the column by comma, and I only mention one split. Maybe there are more than one commas, then there will be, you can take many splits, but there is just a single comma here. So I am splitting it by just one part. After executing this part of code, the location column will be split into two particular new columns, that is lat1 and long1. So I'll run this part of code and I'll even print the head function in order to explore or just get a look at the new data frame that we generated. I'll run this part of code, and as you can see here, the location column got split into two new columns, lat1 and long1, and it got split by a comma. As you can see, there is no comma here, but there is small problem. You don't want a bracket here in the start and the end. So you can use the replace function of pandas in order to replace some values in the data frame column. I want to replace this bracket here, but there will be cases when you want to replace a $sign or you want to replace some alphabets. But in this example, I want to, just for going with the data that is available, I want to replace the bracket here. So I select the first column, that is data frame.lat1, the first column, and I replace the opening bracket with an empty space here. Similarly, I select the second column, data frame.long1, and I replace the ending bracket with an empty space here, and I load these processed column into these newly mentioned columns, data frame lat1 and data frame long1, and I use the data frame.head function in order to see our output. So I execute this part of code, and as you can see here, we have got rid of those opening and closing brackets of our columns lat1 and long1. Now we saw how to split a data frame. Now we saw how to split a column of a data frame. Now we see how to join a column of a data frame. That is pretty simple and straightforward. We will join the columns lat1 and long1, and we will create another new column called as geo. So we'll use a simple plus operator or additional operator in order to join two particular pandas columns, and we'll be separating those two joined values using a comma here. So I mention a comma here, and I create a new column, data frame geo. I select the first column, that is lat1. I use a plus operator and I use the comma here in order to indicate a separation between those two values, and second column is long1 and I mention it here. and once again I use the data frame.head function in order to see the output. I run this part of code, and as you can see here, we created a new column geo. As I mentioned here, we created a new column geo, and we joined the lat1 column and long1 column separated by a small comma. So this is how you can join one, two or multiple columns. Next, what I see here is there are multiple columns which do not hold information, such as the geo, lat1, long1. These are the same values. Latitude and lat1 have columns are the same value. Longitude and long1 have same value. So next, I'll teach you how to delete columns of a data frame. So what you can do is dataframe.drop function. You can use the dataframe.drop function in order to drop the column that you do not require. So I mentioned the column names geo, lat1, long1 and location as I wish to drop these particular columns. Axis is equals to 1, which means I want to drop those particular columns. Axis is equals to 1 means column, and axis is equals to 0 means rows, and in place is equals to true means, as I said earlier, it makes the changes in the same variable. Now similarly I use the data frame.head function in order to see the output. So I run this part of code, and as you can see here, the unnecessary columns or no more required columns lat1, long1, geo and location, these columns got deleted. And another thing that you can see here is there were 25 columns. After deleting these 4 columns, the number of columns have come down to 21 columns now. So this was how we delete the columns of a particular data frame. Next, we take a look at the group by function of a pandas. Group by function groups the data frame based on a value in a particular column. So in this example, I am taking the column to be primary type. It groups the data frame based on the values in the column primary type, and it will group by count. So I'll execute this part of code and you will be better able to understand it. So I run this part of code, and as you can see here, it grouped the whole data frame based on the values or count of the primary type column. So that there are total 372 occurrences of primary type arson. Since we use the count function here, it gave us the count of that particular value in the column. So similarly, there are 49,000 occurrences of the primary type battery, and similarly you can select multiple. You can either use group by arrest, you can group by domestic, you can change the column name here, and you will be able to group the data frame by that particular value in a particular column. So in this example, I created a new data frame in order to not disturb the original data frame, and I printed the head out here in order to get the look and feel of the new data frame. Similar to group by, we can use the sort values function of pandas. Sort value sorting is basically getting the output from low to high or high to low, or we sort it. Basically you just get the output in a particular order. So in this example, I want the output to be in ascending order. I create a new data frame here as well in order to not disturb the original data frame. I use the data frame dot sort values. So I'm sorting the values by values in the column district, and I want the values in the district, I want the sorting to be done in ascending order based on the value in the column district. So I'll run this part of code. As you can see here, the starting value of district is 1. It sorted the rows in ascending order based on the value in the column district. So it started from 1, and if you scroll down, or if you can check out the whole data frame, you will get a data frame where the value in the district is in ascending order. But another thing you can notice here is the index. the index here is not proper, it is not starting from 0. So you use the reset index function in order to get the index in a proper order. But I'll show you another example of sorting. Here we sorted the column district, but here I'll sort the values. I sort the data frame based on the column date. So I use the data frame name dot sort values, the sort values function of pandas, and I'm sorting the values by column date, and I want it in ascending order, and I'll reset the index as well in this example. Next I print the head of the data frame in order to see how it exactly looks like. So I run this part of code, and as you can see here, we sorted by date. So 1st January 2018, 1st January 2018, there are many rows which hold the date 1st January. So these were the just first few rows. So this is how you can use sort values function in order to get the data frame in ascending order based on values in a particular column. Next I'll show you how to iterate through a particular column. This is pretty simple and straightforward. You can select a particular column. I'm selecting the case number example, and and you can simply use a for loop in order to iterate through that particular column. So I create an empty dictionary here, and I'll start appending the values that I obtain from the case number, and I'll append it to this particular list. So I run this part of code, and I want to, in order to avoid any long output here, I'll just print the length of the particular list in order to see if it has iterated properly. So I'll run this part of code, and as you can see here, it has iterated over the whole column case number, and it has appended approximately 2,63,000 values in that particular column, and it has appended it in the list case number. So this is how you can iterate through a particular column. But what if you want to iterate through two columns simultaneously? So you can use the zip function in order to do that. I create two empty lists here, latitude 1 and longitude 1, and I use a simple for loop in order to iterate through two columns. So I use the zip function. I use the data frame dot column name to iterate through the first column, and secondly I use the data frame dot longitude in order to iterate to the second column, that is longitude, and I append the iterated values into the empty lists, and finally I print the length of the list in order to see if it has iterated properly or not. So I run this part of code, and as you can see, it has iterated through all the values in the columns latitude and longitude, and it has print out the length of the list, that is 2,63,000 in this example. Next I'll show you how to split a data frame into two data frames. We'll split the data frame through rows. You can simply use the logic of ILOC. I use the data frame dot I create two data frames. I'm splitting one single data frame into two data frames. So I create a new data frame 1, and I create another data frame named data frame 2. Data frame dot ILOC. Here we select the first 200,000 rows, and we load the first 200,000 rows in the data frame 1, and in second data frame we load the rows we'll start from 200,000th row, and we'll go up to the last row, because I do not mention any value, which means the last row of the data frame. So I'll run this part of code, and I'll print the shape of these two newly created data frames. So as you can see, the first data frame has 200,000 rows, and the second data frame has 63,000 rows. This is how you can use a simple logic in order to split a data frame into two data frames. Next, I'll show you how to join two data frames. It is pretty simple and straightforward. I create a new data frame named join data frame, and I use the pd.concat function, and I mention the two new data frames. I mention the two data frames that I want to join together. That is, I'll use the recently created data frame 1 and data frame 2. I mention the data frame names in this concat function and inside the square braces, and this concat function will join both the data frames. But remember, both the data frames should have the same data type and the same column names in order to join both of these. If that does not match, then you'll definitely get an error. So make sure that both the data frames have similar properties. So next, I use the data frame. I use the data frame name dot shape function in order to see if the data frames have joined properly or not. So I run this part of code, and as you can see, these are the number of rows and these are the number of columns, that is 21. It has successfully joined these two data frames which had shape 200,000 and 63,000. It joined both of these data frames, and we get a new data frame with a shape with a number of rows 263,000 and 21 columns. Here we split the data frame by rows. Now next, we'll use a similar logic of ILOC in order to split the data frame column wise. So I create two new data frames, data split column 1 and data split column 2, just for understanding purpose. I use the data frame.iloc function to split the data column wise. So the value before the column mentions the number of or range of rows. I do not mention any value here, which means that I am selecting all the rows of that particular column, and I am splitting the data frame from the column number 5. So we'll get the first data frame will hold all the rows from column number 0 to column number 4, and the second data frame will hold all the rows but from column number 5 to the last column, that is column number 21. So I'll run this part of code, and if you check the shape, the first data frame has all the rows, but there are only 5 columns as I mentioned here, and the second data frame, data split column 2, has a shape of 263,000 rows and 16 columns. As I mentioned here, it starts from the 5th column and goes up to the 21th column. If you do the subtraction, you get total 16 columns. So this is how you can split the data frame column wise by using a simple logic of ILOC function. Just like the previous example where we joined two data frames row wise, here we will be joining the two data frames, or we will be concatenating two data frames column wise. So we mention the axis is equals to 1 because axis is equals to 1 means column. So we want to join the data frames column wise. So I use the simple concat function. I create a new data frame join df column, and I use the pandas.concat function. I use the data frame names, that is data split column 1 and data split column 2, and I use the axis 1, which means I want to join these two data frames column wise, and I use the shape function in order to see what is the shape of the newly created data frame, and I run this part of code. As you can see here, these two recently split data frame got concatenated using pandas.concat function into a new data frame with the shape 263,000 rows and 21 columns. So we got the original data frame after splitting the data frame column wise and after joining them. So this is how you can join two data frames column wise, but make sure that both the data frames have equal number of rows in order to successfully execute this function. In case if you have different number of rows in the two data frames, then you will definitely get an error. Next, I just see the column names of the original data frame that we used. Suppose I want to change the order of the columns. I want to change, I don't want the ID to be first column, I want the case number to be first column. As you can see here, this is pretty simple and straightforward. You can you can create a data frame name, you can give a data frame name and use the data frame, and you can mention the order in which you want the columns to be. So in this example, I want the case number to be the first column, and I want the location description, which is approximately 8th or 7th column in the original data frame. I want the location description to be the second column, and I want the ID, which is the first column. And the original example, I want the ID to be the third column. So similarly, you can change the location of the column according to your wish. So this is how you can do that, and I'll run this part of code. So run this part of code. So after executing this part of code, we change the location of the column in the data frame. So I'll run this data frame of columns in order to see what changes have taken place. So if you compare these two outputs, the order of the columns have changed. The first column is no more the ID column, but the case number as we mentioned here, and the second column is no more case number, it is the location description as we mentioned here. So this is how you can change the order of columns according to your requirements. So once again, I will print the dataframe.head function in order to confirm that. So you see, as you can see, the case number is the first column, location description is the second column, and ID is the third column. And once again, I will check the dataframe.shape, which is 263,000. Finally, once you've done processing your data frame, you may want to save the data frame either in a CSV or an XLSX file, or maybe you would like to export it to an SQL table. But in this example, since we're dealing with a CSV data since the beginning, I will use the dataframe.toCSV function in order to export the processed data frame to a CSV. So I use the dataframe.toCSV function. I mention the location where I want to store the data. So I'll show you that particular location here. This is the location where I want to store the processed CSV, and I mentioned the name of the new CSV that I wanted to create. So I'll name it as processed. Since it is a processed CSV, since I've done some processing, I just name it processed. You can name it whatever you want. Index is equals to false. Index is equals to false will not create an additional column of index. In case if you forget to mention index is equals to false, it will create a CSV where there will be an additional column of index. That is what you do not want. So I use the index is equals to false in order to not get an additional column of index. So once I run this part of code, I'll be able to export the processed data frame into a CSV. So I run this part of code. So this has successfully exported our data frame to a CSV file. I'll take you there. As you can see, we created a new CSV file here, and I'll open this file in order to see how it looks like. So as you can see here, the first column is case number since we changed the order of the columns. The second order is location description and ID, and here we change the location of many columns here. So this is how you get the CSV after exporting our process data frame. So this was a basic tutorial on Pandas, which is one of the most important Python libraries which are used by almost regularly by all the data analysts and data scientists who use Python. So I mentioned many functions which you will be using regularly, I may have skipped some functions, but in case if you remember any of the functions, then you can mention it in the comments below and I can make another video on those new functions that you would like to learn. So I hope you liked the video. Please click on the like button and subscribe to my channel. Thanks a lot for watching.